So now we know the first two probability laws and part of the third. In this video we'll spend some time talking about the idea of complements and do another calculation. So as a motivating example, what's the probability in 5 coin tosses that I get at least one head? So we know how to do part of this already. We know the total number of outcomes for this experiment. Remember, this is 2 heads in the first toss, or sorry, a head or a tail in the first toss, 2 outcomes times 2, 5 times to get 32 total outcomes. And now we just need kind of the top number in our fraction. We need to know in how many of these outcomes are there at least one head. And I could try to list them all out and then just count them up. This is tedious, and so we'll use an important probability trick to get this answer. Let me introduce the concept of a complement. So a complement of an event A is just all of the outcomes that fall outside of that event. A simple example is in rolling a dice. If the event of interest is that you roll an odd number, then the complement of this event is that you roll an even number. It's everything that's in the sample space but outside of your event. Similarly, the one that we're interested in right now is the event A that I roll at least one head in 5 coin tosses. Now the complement of A is the event that I roll no heads in 5 coin tosses. Now how does knowing the probability of A complement help us to calculate the probability of A? Well, let's take a look at this. The probability of A plus the probability of A complement has to equal 1. This is because every outcome is either in A or in A complement. And subtracting both sides by probability of A complement gives us a formula to calculate the probability of A. It's just 1, probability of everything, minus the probability of everything that's not in the set of interest. With this tool, now let's go back to our problem. What's the probability in 3 tosses that I get at least one head? And let me write, for our reference, the event A, again, is the event at least one head, which means the event A complement is no heads in 5 tosses. And it turns out that this is a very simple event. It contains actually only one outcome, 5 tails. This is the only outcome that doesn't have any heads in it. And so the probability of A complement is 1 outcome, divided by 32, the total number of outcomes. And from here it's quite easy to get the probability of A, at least one head. This is just 1, the probability of everything, minus 1 in 32, this is the probability of no heads, or 31 over 32, close to 1. This has been an introduction to the basic laws of probability, and in the next section we'll spend a lot of time talking about conditional probability and how the third law really helps us out.